Words of wisdom. I would just say whatever you're doing, and stick with it. If you enjoy it, if you love it, you're in a field of study where you guys are doing. You are the future. You're the future of dealing with a lot of problems that the people who came before you, like me and others, are leaving you. Some of those advancements are great, and you're in a field where you're in nanoscience and nanotechnology, where you have the opportunity to solve a lot of these problems and make the world a lot better place. So you stick with that and love it, and really proud of you all for doing that.
Welcome to Navigating Nano, where we explore the multidisciplinary world of nanotechnology with esteemed professors and researchers. Join us as we sit down and talk about the cutting-edge research, career paths, and expert opinions on the expanding world of nanotechnology. This week, Dr. Barner of NC State University joins us. Dr. Barner is known for investigating pulmonary toxicity caused by engineered nanomaterials. Dr. Barner sits down with the Materials Research Society at JSNN to talk about how media portrays nanotechnology and how that works with him or against him. Also, seems like everyone wants to make cool stuff in nanotechnology. What's it like being the person who warns everyone to take caution? Join us as we navigate nano.
Hello, welcome to Navigating Nano at JSNN. I am Zelina, and I have my co-host.
Hi, I'm Theo Nusi.
And today we have Dr. Jamie Barner with us. Dr. Barner his primary work is in toxicology and immunology. And Dr. Barner, would you give us like a brief explanation of your journey to this point?
Thank you. Yeah, it's a pleasure to be here. An explanation of my journey to this point. Do you want me to start from childhood, or should I?
As deep as you want to get.
Any way you want.
I think I've been interested in biology in general since I was a kid, in natural history, and then as I grew older into adulthood, got into college, I began to see a lot of the issues related to pollution in the environment, and whether it was, some of the, I read, Rachel Carson's Silent Spring, and became aware of some of the pollution problems with water pollution. I love the outdoors, with air pollution, and so that began my journey into becoming interested in environmental problems, which led me into studying toxicology when I was in school at Middle Tennessee State University. It got me into a master's program studying pesticides on little worms called planarians. And I think that began it, and I got into aquatic toxicology after that for my doctoral research. And then after I got out of graduate school, I got into air pollution research, and that kind of stuck, and that's what led me to where I am now.
Oh, how exciting. So I wonder, because I think we kind of have some stuff in common when it comes, because I did some work on air pollution, but it was more about like the distribution. So I wonder, why makes you being like more than interested in that area of research of like air pollution on other like type of pollutants?
Yeah, a lot of it was sort of being at the right place at the right time. As I mentioned, I had studied pesticides and aquatic toxicology issues using fish models when I was in graduate school. And when you get out of graduate school, you start interviewing for different positions around the country. And I happened to get an interview with a fellow named Arnie Brody at the National Institute of Environmental Health Sciences, and he was studying lung toxicology and the effect of asbestos. And so I went to work for him. That's what got me into it. I don't know if I would have stuck with aquatic toxicology if I had the opportunity. Mm-hmm. So a lot of it's what opportunities there are presented to you where you go. Yeah. And I was broadly interested in all of these things. So I had to sample, I think, all of them, and pulmonary toxicology or lung toxicology sort of stuck with me as my path that I remained on, I guess. But I'm interested in all of it.
Okay.
So cool.
I read in your bio that you received your PhD at Mississippi State. Go Bulldogs. I have a quick question. Do you own a cowbell?
I don't. I don't own a cowbell, I'm sorry to say. I had forgotten that. No, I remember now, yeah, the cowbells were used at Mississippi State a lot at the football games. Yeah, I was in the lab too much. I didn't have time to go to football games.
Okay, so I have family members that have asthma and have other respiratory disorders. I like that during your presentation you mentioned mesothelioma, because that's one of the things, like, they advertise it, but what is it?
Yeah, mesothelioma is a bad one. It's I say all cancer is bad, but there are some types of cancer that are more aggressive than others. And so mesothelioma is a very rare cancer. Most people that don't get it, you can get it if you weren't exposed to asbestos, but almost all of the cases, or the majority of the cases, are from individuals that were exposed to asbestos, working, in the brake lining manufacturing area, or demolition of houses that contain asbestos. Some line of work where they got exposed to it, then maybe 10, maybe 20 years after that exposure, they would develop this cancer. And then once they got it, it progresses very rapidly and would kill them. But it's a specific type of cancer that develops on the lining of the lung called the mesothelial lining. So mesothelioma are mesothelial cells that have gone awry and proliferated.
So I just wanted to remind our current audience that they can jump in and ask questions at any time to our guests, so we can have a more dynamic conversation here.
Yeah, sure.
So, and I was very excited that you came here to talk to us.
Thank you.
So, because I saw we have a lot of common the things in common when it comes to research, and you said something that really stuck with me. You said you are looking at studying the dark side of nanoparticles. I really like it, because I think that's the same thing I'm doing. Kind of see how they're good, but they also have a dark side, and we should be kind of prepared for it. And the reason why my question is more related about you serving as a U.S. representative for the World Health Organization panel for drafting criteria document on immunotoxicity for engineered nanoparticles, and I work with them. But the thing that I've realized in that field is there is not much policy about regulation of nanoparticles. They still consider in the same, if I'm not mistaken, they're still regulated the same as their bulk counterpart. But what do you think about it? Do you think we should have a specific regulation that target only nanoparticles, and also so we can differentiate them from their bulk counterpart, or just like, okay, we can do something else?
Yeah, no, it's a great question. I think we should. For example, I think one of the landmark studies that was done in the early '90s with Nano, that kind of drove this point home was by a fellow who is a professor at the University of Rochester. His name is Günter Oberdorster. And he did one of the landmark studies with Nano with titanium dioxide, looking at relatively larger titanium dioxide particles and very small titanium dioxide particles, and showed that the smaller ones were much more toxic than the larger ones, which brought home the point that the reason that nanoparticles are more toxic than larger particles is that they have way more surface area per unit mass. Mm-hmm. And that's really important, mm-hmm. per unit mass, right? Mm-hmm. Regardless of what they are, I mean, some chemicals are more reactive than others, but relatively larger titanium, when I say relatively larger, maybe a 1 micron sphere, diameter sphere of titanium dioxide is relatively inert, versus a 20 nanometer titanium dioxide sphere, a gram of each, which one is more toxic? Well, the nano is much more toxic because of this surface area. Mm-hmm. So yeah, for that reason alone, I think that elemental forms should be considered perhaps individually, but if there's evidence that the nano size is much more toxic, then yeah, they should be regulated differently.
But what do you think could be done in order to push such type of policy?
So I guess it's like any other policy. It's the ongoing issue right now in North Carolina, and I know I'm switching gears here, but it's still toxicology with the perfluorochemicals, the forever chemicals in the Cape Fear River that have been dumped by industry there for years. That's what you hear on the news, the Gen X story, which is one of the emerging perfluoro or PFAS chemicals. Mm-hmm. Right now, that whole exercise is going on in terms of how to regulate those. There's thousands of them. It's a similar scenario with nano. There are thousands of types of nanoparticles. How can you possibly regulate them all? I think there has to be some common rules about nano and some common rules about PFAS, that they can be grouped, right, based on the scientific evidence that they cause disease either in experimental animal models, based on the evidence from epidemiology studies that they cause disease in humans. There's less of that in humans for nano, simply because the exposures are probably, it's relatively new. I mean, we've been exposed to nano. Yeah, we have a question over here.
So I have a question, you have done a lot of studies with your colleagues about the nanoparticle toxicologies. So is there depending on a study has been done, how you are going to group the nanoparticles and their toxicity? These are the less one and these are the moderate toxic and these are the higher toxic, so that the future who are working, future students or colleagues who are working with the nanoparticles, their future is going to save with that.
Yeah, I've been involved in some of these consortium that have been either funded through the National Science Foundation or the National Institutes of Health that try to do these, what they call banding, mm-hmm. or grouping of classes of nanomaterials based on their what they call SARS, S-A-R-S, or structure-activity relationships. And what that means is, you take the physicochemical properties of a group that have similar physicochemical properties, and then you ask, do all of these do something similar in terms of either A, causing adverse outcomes in experimental animals like mice, and then B, what is the evidence in humans that their occupational exposure are there adverse outcomes. So there's also this, what goes along with this banding of groups of engineered nanomaterials, or some types of analysis, for example, these adverse outcome pathways, where you try to fill in some of the gaps to make some more, broader assessments that can be useful for regulation in the future, I think. I don't know if that answered it, but.
Yeah, kind of.
Kind of. It's getting there.
Yeah.
At least keep the discussion going.
Okay, I have a question. So in our lab, we study the interaction of nanoparticles with microbes, mostly looking at gene expression. So with at the trajectory of nanoparticles and engineered nanomaterials in the environment and exposure to it, what do you think the health trend will become in the future as nanomaterials become more commonplace?
Yeah, health trends. I think from my perspective, it gets back to risk and benefits. Like with microbes, there's great promise for nanomaterials as antimicrobials, right?
Yeah.
So that's a benefit. There is great potential for nanoparticles and nanomaterials to be delivery systems and anti-cancer drugs on the nanomedicine platform. That is a huge benefit. There are great benefits, I think, coming down the line, and they're already being developed by nano engineers to really solve some of our energy problems, which is a huge issue that's related to climate change. I mean, how are we going to ever get off of fossil fuels, right? And reducing carbon footprints and reaching zero, carbon footprint in the future. I think nano holds great promise for doing that, for making more efficient batteries, solar panels, all of this. So I have a lot of hope for nano. Now, again, the dark side.
Yes,
the dark side, that we have to be careful with anything.
Yes.
Anything humans develop, as we know from history, we have to be very careful about what we do and what we put into the environment, that we don't want to pollute the environment at the same time we're trying to solve some of these problems. We don't want to hurt people at the same time we're trying to cure disease.
Yeah, because so there's been studies and people have seen, like, with the amount of plastic pollution that the average human has a credit card's worth of plastic within their body.
Yeah.
And we don't have any mechanism for excretion for a lot of these things. And what is the potential health risk of all this nano accumulation, like this accumulation of nanomaterials?
Yeah. We don't know the answer to a lot of these.
Yeah,
I know that's like one of these things I think about. Even though I'm in nano, is very progressive, but if we ingest these things or get these things in our body, what is the long-term effect? And then genetically, as these nanoparticles affect our gene expression, our genes, what are we passing off to future generations, and what evolutionary phenomenon may happen from this boom of nanomaterials? Like, I think about that sometimes.
Yeah, I think it's more than like, for me it's problematic. Nano is great, it's awesome. We have all these new inventions, devices, everything is very sophisticated with nano, but like you mentioned, the dark side of it can be really, really dark. Dark in the concept of how the environment is going to be changed in a hypothetical, highly saturated, polluted, environment with nanoparticles. We don't want to go to that level of chaos. So I think it's more than important to kind of start the research and understanding the interaction with living organisms for now. So if we can mitigate some of the negative effects, that will be like as more beneficial than getting to a part where it's going to be just like unbearable for everybody.
Yeah, I'm not so concerned about the field of nanotechnology in terms of the diversity of different materials that are being developed for specific things like energy and nanomedicine. The thing, and I think we have to be careful not to. Someone brought up in my seminar, we have to be careful not to be alarmist. Yeah. I mean, I was always trained as a toxicologist. It's the toxicologist's role to be the voice of reason in terms of being concerned and trying to figure out some of these things, but also keeping a cool head about trying to solve some of these problems. Now, there are obvious problems in the environment, like we brought up micro nanoplastics. That's a big problem. Perfluorochemicals, that's a big problem. Nano, it's turned out to be maybe isolated hotspots of problems more occupationally, at least from the data I've seen in human exposures. If you're in an industrial setting where you're producing a lot of carbon nanotubes, for example, or any other kind of nanomaterial, you don't want to be inhaling them. And a lot of the work that's being done by the National Institute of Safety and Health, NIOSH, in Morgantown, West Virginia, addresses a lot of that occupational exposure. But yeah, I think we can be optimistic and concerned at the same time. I always tend to be. I want to be an optimist. I don't want to. I want to fix these problems.
Yeah.
So, we always say prevention is better than cure. So, what are the precautions should be done? Like, what are the ways you have done a lot of research on these toxicology effects of nanoparticle or material. So, what are you approaching to that, to solve this problem or to regulate this problem, or to, what are the precautions you are taking for it?
Well, I think, let's take the specific type of nanomaterial that I focused on in the seminar, which were carbon nanotubes. A carbon nanotube isn't a carbon nanotube. There are a lot of different types, so we need to figure out which types, do the toxicology testing to determine which type might be more dangerous. The International Agency for Research on Cancer, IARC, which is part of the World Health Organization, met several years ago and assessed this broad panel of different types of carbon nanotubes and found only one, the type that I mentioned, Mitsui 7, these needle-like materials, these carbon nanotubes, that were a Class B carcinogen. And so that's an example where you look at a broad panel of materials and you go, all of the other ones, there may be some toxicological issues of it, but this one looks like it could be a carcinogen. Let's not use that one anymore. And so, you can ban that one, but that doesn't mean ban everything, because there's a lot of potential uses for the other ones. And the biggest hazard for these things, if they're airborne and someone inhales them, so let's try to control that scenario. Once they're in place, once they're in a matrix, you can't inhale that. It's in a car bumper, for example, lightweight, fuel efficient, makes cars more fuel efficient. That should be good. You do have to consider other end of what they call the life cycle of nano. So what happens now if the car bumper goes into a landfill and it gets, broken up, and then somebody does get exposed to it again. So you have to consider those things. But I think that sort of practical approach means that you can figure out which ones are the most toxic, avoid those, and move forward with the other ones.
Thank you so much.
Any other question? Oh, yeah, go ahead.
I'm also a very hopeful person, and in recent times, I was listening to a lot of scientists in YouTube or other places, and they say that as a human species, we face a global problem now. That is global warming. Can you give us an idea regarding what promise the nano has to fight this global warming that we are sure going to face?
Yeah, it's a great question, and I think I hit on it a little bit earlier, but it's my understanding that the same reason that makes nano potentially toxic, which is surface area per unit mass, also makes those materials fantastic for capturing things like solar radiation, for solar panels, for making batteries more efficient, smaller, so that we can solve some of the energy problems that we have, to take our reliance off of fossil fuels. So in that sense, that's one of the great benefits of it in terms of solving the climate problem, or at least being a part of the solution to solving the climate problem. I think I had another example too. I forgot what it was.
Another question?
Yes, if it helps us fight the global warming, we should be giving more concentration to it. Like in our lifetime, we may not face the bad effect of global warming that much, but in the generations to come, we cannot avoid it.
That's right. And I remember hearing for batteries for electric cars, one of the things that is one of the environmental issues of concern is mining of lithium, which is required for that. And so if engineered nanomaterials that we can make in the lab can reduce our reliance, and I'm not an engineer, so I don't know. I'll take all of this with a grain of salt, please. I'm just saying broadly, with all the bright minds we have in this room and in this facility here, at JSNN, that if you could come up with ways with engineered nanomaterials to use in batteries to replace reliance on things we have to dig out of the ground like lithium, that's a great plus, and it also helps with the climate issue.
Thank you.
Yeah, thank you.
I had.
I did have a question. So, personally, I feel like in any field, nobody wants to be the what could go wrong guy, but you kind of made like a career of it. I guess I kind of have two questions in one. But one, how is that? Especially in something that's like really like supposed to be like the future, and also if you think about like the most dramatic thing we could think of is like media, and we see like nanotechnology, nanotech in the media. I was wondering if you could give some thoughts on that. It's like, does it work with you or against you, or like kind of like?
You mean dealing with the media?
It's even from movies to like the news, local news or something like that. Like
I love movies. I'm always using movies as an example for a lot of things that I bring up in my lectures in toxicology. And it's a great point. And I think we do have to think about what is the worst case scenario. So I don't want to be sort of the toxicologist, doomsday guy, but we do have to consider, because real world problems in toxicology do happen. We're in the midst of a number of them right now. I brought up some of these PFAS, microplastics, climate change, which is partly toxicology, partly not. But it is due to a toxic effect of carbon from petrochemical burning on the environment. So it is kind of a toxicology issue. I like to bring up these things because these are real world problems we have to face. So somebody's got to bring them up, and then we have to be the optimist and try to solve them. And then in terms of the issue of the media that you brought up, dealing with how you present these issues to the public, I think there is a responsible way to do that. And as a matter of fact, I teach a course at NC State called Responsibility in Science. And last week, one of the presenters we had was how to effectively communicate to the public. And the specific example my host was giving had to do with the North Carolina Gen X PFAS problem, and telling people, we just took your blood and we measured PFAS in your blood, and you have higher than the national average. And immediately the questions that come back from these individuals is, what does this mean for me? Is it safe for me to drink my water? Those types of things. And I think there are, responsible ways to respond to that without scaring people, but also trying to look out for their health and trying to fix the problem. I think the same goes with any communication with the media that turns up in the news, because you know, the people in the media are only doing their job of trying to get information out to people. Now, you know, there is the criticism that they're trying to sensationalize on things and make money too.
Mm-hmm.
And that is true, and there has to be a responsible way to do that.
Yes.
And so I think it's our job as scientists to keep a balanced view of things and not try to alarm people more than necessary, but at the same time make them aware of the problems. And this is a serious problem that has to be dealt with, or we predict, based on the best of our knowledge, that this is what's going to happen. And that's kind of the issue with climate change. There's so much information now that this is the direction that we're going on, or going into, that you know, there are uncertainties in everything, and with nanotechnology, there are some uncertainties, but there's no reason not to move forward with the nanotechnology platform and, you know, industry, because of all the benefits. We just need to be responsible and careful in the way we do it. And as problems crop up, we have to deal with them so that we keep people safe and keep the environment safe.
So back to movies. During your talk, during the seminar, when you said dark side of Nano, like I pictured Darth Vader in a lab coat with Death Star in the background.
I had
like,
that too. Being a nerd, I saw Darth Vader.
Yeah, I saw the
I like
whole-
that.
I have to be careful of the imagery
Star
I
Wars.
get.
So I'm gonna maybe steal that from you. The dark side of nanoparticle. I
you
like
probably
that.
should put
I will
Darth
do
Vader
that.
in a lab coat.
I would do that.
That'd be a great song.
Yeah, or like, you know, Dark Side of the Moon, maybe Pink Floyd or something.
Yeah, you could play that in the background.
like I had the whole thing
Yeah.
going in my mind.
Like, ooh, it's
But
coming.
a lot of times, like we were saying with the media, they communicate things on the media, and then there's some kind of miscommunication about it in the public because they really don't have understanding. And some people know that I have, you know, a chemical background, and they ask me these things, and they're like, "Oh, so are we gonna die?" It's like, no. Like, that's the thing is, like you said, with media sensationalizing things, I think that the media really thrives off like fear and scandal, and anybody that goes against the norm kind of gets crucified, pretty much like Dr. Fauci doing the whole COVID thing. It's like, okay, I'm telling you this for your health, but then we have the media with this other side to whatever we have, telling people, oh, the vaccine is rearranging your DNA. It's like, I'm not sure of how we can change that,
Like,
but I
how do
think
we
that's
cope
like
with
how do we cope
How
with?
do we slash that narrative that is so
And how have
toxic
you done
for
it
the
in your
public?
career, like to put a balance between the sensationalness of new scientific information and what really is going on?
Yes.
Yeah, well, I only try to talk to the media about things I feel like I'm qualified to talk about, for one thing. And I was actually, you know, taught this by a fellow at NC State in the media who kind of gave me some tips on how to communicate. And one of the things is, you know, don't go outside the bounds of what your expertise is in terms of, like, I probably wouldn't comment on issues related to COVID because even though I'm a toxicologist, I'm not a virologist like Dr. Fauci, and so I wouldn't go there. Yeah, where are we going with this?
I don't know. It was just that's like one of
I thought
the
you were going to
things.
quote another movie.
No. But,
Wait, give me a second. I can get back to you.
Yeah,
but that's,
so-
like, that's one thing that makes me nervous about, you know, being a prominent person in the field. Is like, okay, they're gonna call on you to speak or be an expert, and then the way the media is, they misconstrue everything.
Okay, so I want an example of this. Was I was interviewed once by one of the local news media outlets. I won't say which one. It had to do with asthma, which I know something about, in schools, and black mold growing on the ceilings. And there was a student in the classroom whose parents became concerned because the student had asthma. She was having more asthma attacks because she was in this classroom. They interviewed me about you know, my scientific opinion on what should be done about this problem. And I said several things. One was black mold can, like nanomaterials, that can exacerbate asthma if you have pre-existing asthma. That was a fact. Another thing I said was an opinion that I said if I had a kid, I wouldn't want them in that classroom. And I regretted saying that because they quoted me saying that on the news. And when I went home and watched it in the evening, I went, oh man, I really said that. And so I was warned previously, be careful about rendering opinions about what you think. Just stick with the facts. Having said that, you can give some recommendations. Like, Dr. Fauci has recommendations on whether you should wear a mask or something because there's scientific information that. But it gets back to there's some responsible ways to communicate with the media, and there are some relatively, I don't know if I want to say irresponsible ways, but yeah, they could be irresponsible.
Yeah. Okay. So switching gears and coming back to, your academic, journey as a mentor. So I wanted to ask you what mentorship is for you and what type of relationship do you have with your students?
Yeah. So mentorship is my favorite part of my job. That's why I like being in an academic setting, mentoring graduate students and undergraduate students in the lab. It is definitely my favorite part. You can watch the students grow over time intellectually in the lab and learn new things, and eventually, it's kind of like I've often told people I have kids at home and I have kids in the lab, and they're all very special to me because I like seeing them grow up and be successful, and with my students, become scientists, and I'm passing the torch along, so there's nothing better than doing that. I think I have in that sense, the best job in the world, that I can publish all the papers I want to, but at the end of the day, I don't want to minimize my impact on the scientific community, but I think, as scientists, there are some scientists who are going to go on to be Nobel laureates. So I'm not one of them. Okay? I think I do pretty good work, but I think my biggest contribution to science is mentoring.
Oh, that's very interesting.
So I'm going to take you back, if you can remember, like from undergrad, if you can remember. Since we're speaking on mentorship, what person in your academic journey, thinking back to undergrad, made the most impact on who you are today and how you reach where you are now?
Wow, undergrad. You might need to put me under hypnosis to take me back.
Okay, well, any point in your graduate, or either whether undergrad or graduate.
This is going to sound like a really weird example, but I remember when I was a freshman in college, I knew I wanted to be a biologist, and I probably shouldn't tell this story, but it's okay. I was in general biology, and the department head was teaching this class, and it was a huge class, and we were told he was going to weed out about a third of the class. You're going to fail. And so I thought I was well prepared to go into college, and took my first test in the biology exam out of the 4 or 5 tests you take during the semester, and I failed the test miserably. I won't tell you what I made on it because it was really bad. And the department head afterwards came in the next day and said, any of you who made under a 60 on this test should find something else to do. You shouldn't. If you wanted to be a biologist, you need to do something else. And so I know you were looking for a story of great positivity, of someone who inspired me.
Yeah.
This was inspiring to me because this man scared the hell out of me and said, you're not going to be able to do this career unless you go back and study a lot harder. And then I did have other positive influences in graduate school, like, my mentor for my master's program and my doctoral program and my postdoctoral program. They're always fantastic mentors in terms of supporting me, and so that was a little bit of a strange example, I know, but I couldn't think of anything else from undergraduate.
But I think it's still part of the experience,
Yeah,
so it's good to know that you can be scared.
Oh, I studied
and be
after
inspired
that.
by that fear,
Yeah.
or it's not
And
always
then-
like rosy all the time. So.
It's also good
Yeah.
to know that, your first pretty much academic, post-secondary academic endeavor wasn't successful, but you were still able to make it. So the first
Yeah.
note
So your
is
first-
not a closed book.
Yeah, I knew I wanted to be a biologist, and I didn't want to give up on that.
That's very inspiring.
Yeah. Let's talk about the fun stuff.
Oh, I thought this was fun.
Oh, that was fun.
I was
Like, it's
having
super
fun.
fun. Like
Oh, okay.
super entertainment type of fun.
Okay.
So that's why we want you to talk about. I read that you like to go fishing. I think you and my advisor will be
Yes.
like super buddies because he
Yeah.
love fishing. And
hiking.
Yeah, and hiking. I
Yeah.
saw that.
Yeah.
And playing guitar.
I do.
Okay.
Yeah.
So what are the
Guitar?
yeah?
Bring it on.
Are you in a band or something?
I was in a little university basement band of some professors that they never let us out of the basement, really, because we weren't that good. I think we played a cookout one time, but that was about it. But no, I do like to play the guitar, and mostly it's for my wife while she may be cooking or something, or for the cat and around the house. But I do enjoy playing acoustic guitar, sort of the finger style picking, and I like hiking and kayaking. I love getting outdoors and fishing. I don't catch a lot of fish, but I like fly fishing.
Yeah.
And you don't catch it if you want to catch a lot of fish. You don't use a fly rod.
Yeah, you and our advisor will be.
Yeah, we'll be like
buddies.
best birdies because he loves fishing.
What's your favorite hiking trail?
Oh, wow. I recently, there's a bunch of good ones. I recently did one this fall with my son south of Asheville. It's called Shining Rock Wilderness in the mountains of North Carolina, south of Asheville. And I think that's got to be one of my most favorite ones because you start up at very high elevation in these Black Balsam Knob, I think it's called. Mm-hmm. And it's cold at night, and then you hike down to a lower elevation in the Pigeon River Valley, and it's just beautiful. You go through a lot of different changes in, what do you call it if you're an ecologist, the different regions of trees, and it was beautiful. I got a bunch of nice hiking trails, though, that I could tell you about if I had more time.
Well, I'm not a hiker. I'm clumsy. I will be the only person that, may have to get airlifted off the mountain. I might trip over my own feet. So, yeah, I probably won't be able to join you on that endeavor.
Yeah.
Do we have any more questions?
Any other question from the audience? Yeah, guys. Gary's here.
We had some questions over lunch. We had Q&A over lunch.
Oh,
so.
okay. So.
Well, if that's all, we'd like to thank you for your time, Dr. Bonner.
Yeah,
I
and
really enjoyed
before
this.
we end, I wanted do you have any last word of wisdom for our listeners?
Words of wisdom. I would just say whatever you're doing, and stick with it. If you enjoy it, if you love it, you're in a field of study where you guys are doing. You are the future. You're the future of dealing with a lot of problems that the people who came before you, like me and others, are leaving you. Some of those advancements are great, and you're in a field where you're in nanoscience and nanotechnology, where you have the opportunity to solve a lot of these problems and make the world a lot better place. So you stick with that and love it, and really proud of you all for doing that.
Thank you.
Thank you so much.